Hello there. Today I wanted to talk to you about another YouTube channel, which is called Cinema. They do these long format videos about science and movies, and they mix the two together quite artfully. So you have here The Office, you have here Monsters Inc. and stuff. It's a really great channel. Despite being in French, and because they only have 123k subscribers, I figured out that, if the four of you could go to his channel and subscribe, it would be very much appreciated. Now, alright, what happened for real is that I lost a bet. So, let me tell you first the story. I know the guy who makes this video, a good friend of mine called Jean-Baptiste. We made a bet and I lost it. I bet that Mad Lions would win in a League of Legends match. The Worlds are coming quickly, so expect me to lose more bets. But when you're a fan, you're a fan. And the bet was that if I won, he would make a video on Datastar, and if I lost, I would have to make a video about him. So Datastar just lost 123k subscribers. I guess this is the kind of things that happen, but here we are. The thing is, doing a video about him was kind of complicated because his YouTube channel is very successful and he's not only a YouTuber, he's one of the greatest video games designers that I know. He's a very smart guy all around, he can do a lot of stuff, and so I tried to, to find the right thing to do. But, this guy, he made a website called The Shape of Movies. And here it is. It's still online, and you will find the link in the description, and I encourage you to go watch it. Now, you can see here we have a list of pretty good movies. For example, let's pick 2001, and when you click on it, you have this frame, right? Where every frame of the movie was taken down, dissected into these little colors. So the colors that appear in the scene, the red here, the big dark of the space. What do we have? We can find the psychedelic voyage somewhere around here, and it makes for it's really nice. It's really nice, and I figured out why not remake it with Datastar. And this is what we are going to build today. I am very happy to present you the shape of YouTube. The shape of YouTube is exactly like the shape of movies, except it's on YouTube videos, and you will be able to make a frame out of your own videos. So for example, I did it here with 2001. It's not as nice as the original, but you kind of get the point. You get all the frames from I just took the space delirium episode, but here it is. And monkey, you have monkey here. You can make a lot of videos, so I want to show you how it works. You can just take a video on YouTube. Let's take one. For example, let's take the trailer of the Cinema channel. We copy the link, we put it here, and then I want you to watch closely what will happen when I click submit. Yes, chief, one moment. Fetching metadata, getting video info. I am not touching anything. And you will see the live updates as the video is downloaded on my server. Downloading teaser cinema in 360 pixel because we wanted to speed up the process, then extracting frames. And the video is split frame by frame, then it's analyzed into its different colors, and then you're redirected to the color analysis of the video you submitted. Do you see here? Alright, some some blue at this part, and the black and yellow of the title at the end. Today we are going to see how to make it with Datastar. This is one of my biggest projects in a long time, so I figured out a little schema would help. It certainly did help me. How do you go on to build an application such as this with long video processing on the backend? So when the user submits a link to the server, what we are going to do is to start a worker in a parallel thread, which will in parallel start downloading the video, splitting it in n frames, and analyze these frames. In the meantime, we are going to create a queue of events that the user will listen to. This is a very common pattern in Datastar architecture called CQRS. We are having a meetup soon about it. If you want to join, see you on the Discord. So they will listen for the updates as the worker is processing the video, analyzing it, updating the database, putting messages in the queue. When the worker puts done messages in the queue is smart enough to read it, inform the user that everything was ready, his page is now ready to be viewed, and it is redirected to the final page. So this is what you saw in the example just before. And we also have a gallery with the latest videos that were processed. You can see monkey with gut. I think I've shown you this one. This is my video clip where I go from a 0 to a hero, and we can see, I like this one because it goes from black and white to a lot of colors afterwards. And if you click the link here, you are redirected to the corresponding video channel. We have yay boy. Just why these are small beams? There is a limit, you have to know, on the website. You can't only put under 1 minute videos. I don't want my server to be processing entire 4K movies, so we are going to be downloading in 360p and only under 1 minute video. Good enough for a proof of concept. Anyway, I don't expect this website to last very long. You know, we are on the verge of copyright infringement, legality. I don't know if I have to take it down. I'll take it down. But I do have to show you Ma, which is a really nice video in 3 panels. First panel, you see an outdoor, nothing in it. An outdoor, but by the color change you can figure out that something happens. A cat. I really like this video. Let's, just for the pleasure of seeing it again. Alright. One more look at the architecture document. We have it all planned. So now how would we approach, building it with Datastar? We are going to be building it with Sanic as our Python backend framework. We are going to need async.io, of course, import OS, UID, JSON. We are going to use Redis for the queue and the messaging system. Some logging would be useful. Then we import Sanic. So Sanic and the HTML response. We are going to use Passlib. I can move that up, I guess. We are going to import, as usual, the SDK for Datastar. And we are going to use from process import video. This is not a classic case of Python import solution, alright? We are going to see it later, but we are going to call this function on the URL of the user to start processing the video. We are going to have a talk about async in this video in depth. My main computer is in Windows. My VPS is in Linux. So the AI found me this little code snippet to ensure The Windows event loop supports subprocesses, whatever. The development of this app was complicated. I mean, developing it was fine, and then putting it live between Windows and Linux, they have different async behaviors, so you have to watch out for that. There is a little piece of code that might be helpful to you to set the event loop policy. Let's move on with the classic setup. Sanic, we declare on static folders a video folder where we are going to be storing the videos of the users and the index file that will be returned on index.html. I'll get back to it. Later, we configure the logging. We start our Redis client to exchange messages. We make sure that after the server stops, the Redis client is closed. So this is the nice little wrapper that Sanic provides. And on response, we make sure that we have a user ID on every request. User ID being just a unique identifier cookie that we slap on every request. Alright, we can now take a look at the index.html file. Very standard, we import the Datastar and that's all. Alright, we have some custom CSS, there will be CSS at the end of the video. Datastar, and then we start with body, the title, the form to submit the link, so we are going to be using a pretty standard HTML form, which is why we are going to say data on submit post to the process root, and we add this little content type equals form so that the content of the form is included in the Datastar request. Once again, we have some classes from Gold CSS, go watch the video. And then we have here a data on load, which will get the status updates. So the status updates is the video being processed or downloaded, or which frame is being processed, what you saw. Like, this is where we are going to be putting our percentage bar to indicate progress. So we just call a little data on load with it. We are going to be focusing a status div, so I declare an empty div but with an ID, and another empty div with an ID, gallery, to put the latest videos in the index file. So, status updates, very simple. We are going to be listening for any events happening on the user video. We start first with populating all the videos that we have, so the index will always be up to date. I could build it, statically whenever a new video is added. Most people would have done that, but since we are going to do that later, I'll figure out this will be a good first way to see what is happening. So for any video in the video folder, we're going to be trying to get its name. We are going to be loading its frames, so we can take the first frame of the video as a kind of a thumbnail. We're going to add to our list items a link to the page. So because we are building it on the backend, we are going to be creating addresses, /v/feed ID. Then we are going to use this v route as a good MPA route. Image source equals thumb path, again name, and we put the name inside it. And this is how you get all these videos with a nice thumbnail and a little link that will take you to the corresponding page. You can look at the address bar. We have /v/a big ID, the ID of the video. This was very easy. So how do we ensure that information is up to date and the state is correct in Datastar? We just ask the backend and send the latest news. Alright, but this is like a one shot. then we just called yield. If it's really a one shot, you can call return, patch elements, and you return the HTML. Notice the ID gallery, because we are patching the gallery element. Alright, now for the fun part. How do we listen in continuous for anything that changes? You've seen this pattern a lot in this channel, but it's never bad to look at it again. We take the user ID from the cookies. Right here, we create a pub sub publish subscribe object with Redis. We await to subscribe, so we take user and the key then is user ID. We are telling our backend, hey, this user is probably up to something. If we do anything on the backend regarding this user, this is where we are going to put our messages, and this is indeed what is happening. We say async4 message in pub/sub listen, so async4 will wait indefinitely if there are no messages, but as soon as there is a message in the pub/sub, it will take it. If the message is message, because you have like basic information. This is not a course about pub/sub, alright, but if you have any questions, you put them in the comment or in the Datastar Discord. And depending on the status, for example, if the status is complete, we are going to return a div ID status with a max progress bar, as you can see here, and we put done, processing complete, redirecting, blah blah blah. We inform the user that is going to be redirected. We break from the async4, and then maybe I can hold that for a moment. We unsubscribe the user, we close the pub/sub, and we redirect him to the page that he wanted. If the messages are running messages about the progress, we just can embed this information in what we pass down between our methods in the backend in a progress field, and it's going to be exactly the same. Value equals progress, and progress HTML, blah blah blah, and the message will be here, status and message. And we yield and yield these elements and patch them as they come. Now, when the user submits a link to start this whole rigmarole, we have this process route right here. We take the form data with this line. We then say, this is the URL, this is the quality. I wanted to make it possible to download in higher qualities, but you're not going to have that except if you have LEG Pro. I would say more of that later. But let's say, okay, quality is 360p, user ID here, and then we use async.io to say create task. So start Disco routine object, spawn a task, process video URL, user ID, quality, and we inform the user that the process has started. You see that from this route we are returning, so this route is a one-shot. We are just returning, yes, it started. This is not strictly CQRS, but this is just for information. In pure CQRS, you would return a 3 or 4 here, and the user is listening to any progress, and the first message of progress will be got it, starting your task. Which would have been better, but hey, this is the code I wrote, so this is what you get. This process video task is going to be a big bite, so we are back at the drawing board for this one. Alright, before we look at the backend process, I want you to understand that the server will have to do a lot of stuff. It will have to download the videos, it will have to process the videos, it will have to serve the request, in the meantime, so we have to use async code in here. A quick recap on how I see async at this point. The way I see async is that you have a boss here, which can tell workers to go work on a table. Table being your server CPU, you know. For most cases, it works really fine because you have nice workers. Async code in Sanic, you can tell the worker to go work at the table and then stop working, and he will take his tools and go back, and you put another worker, and the main loop is trying to run everything smoothly. The problem here is we are going to have two more types of workers which are really not nice at all. CPU intensive and IO intensive workers. CPU intensive workers is going to be, sorry for that, is going to be, you know, task lab processing the video. Processing the video is going to take up a lot of CPU time and power, and don't leave any for the main loop. So the main loop will not be able to coordinate this worker when he goes to the table. You know, it will take a lot of processing power and time just for himself, so it will be a problem. And then you have IO intensive worker. So this one is communicating a lot with other processes. For example, downloading a video. It's like he's talking to a remote server, he's talking to YouTube, and he can't, you know, pause the communication. You have to wait for him to finish talking at the table, and while you are waiting for him to finish, you can't run the main loop. You can't make the boss function as it should. This is also like when you are opening and communicating with a database on the backend. If your database is good, it's going to take you know, not much time, but this is the kind of bad workers we're talking about. Now, the easy solution is to get more tables. You know, you get 3 tables, one when you run your stuff, and when CPU and IO workers come, you tell them to work at other tables, so they have some space. So this is when you have a multi-core processor. It's like having multiple tables. You have one core of the processor that can work on some stuff, and if you have to make other operations, you can parallelize them to another worker. The thing is, we don't have this luxury. We're on $3 per month BPS, where we are running dozens of Datastar apps, and we don't want the server to be overloaded. Fortunately, since Python 3.9, we have a function which is called asyncio2thread, which will kind of create a second table. What it will do is it will split the table in half and make it seem like it's 2 tables. So it will take care of that, and Python can have multiprocessing on one core, which is kinda nice and which will be useful because we are now diving into the code of process.py, where we import process video. We are going to import a lot of stuff: OS, UID, subprocess to run, you know, commands from the command line, passlib pass, async IO, numpy, p, scipy. This is all going to be to analyze image, the frames of the video. TinyDB will be, as usual, our database, JSON, of course Redis async IO to send messages back. So this is also very practical because you have one process that can put his message in Redis pub/sub, and the other one is listening on the same pub/sub. So this way we have a central communication bus. Logging and color sys. Let's get going. I want to start at the top level process video, so the function that we were calling from our app. we see that it takes as inputs the URL of the video, the user ID, and the quality that we set to 360p. I log some stuff, I create a folder for the outputs of the video. Okay, we make a folder to put all data in it, we create the connection to the Redis client, we define a quick handler to publish an update, and then what we are going to do is make a big try block. And if there's anything bad happening in this try block, we say pop, something failed, details, status equals error, we put the debug message, process equal 100, and we publish the update. Alright, this is going to be very useful because this function will be calling other functions, and if any other functions crash, it just has to raise an error and it will be caught by the top level one, which is why I wanted to start with this one. First thing we do, we say to the user, yes, we are starting with fetching the metadata, getting the video info, progress equals 5, we are beginning our journey, we are beginning our descent to hell, and we call our first function, please welcome get video info. I go back to it, and before showing you get video info, you have to watch for the classic Windows Linux shenanigan on the event loop. Get video info, we are going to call YTDLP, which is a very useful library to download YouTube videos. -G, cookies, click download, URL. What's important here is that we are skipping the download, so we want just to get the info of the video, because if it's longer than 1 minute, we are not going to accept the video. This is not your server after all. But you're welcome to play with the link in the description, right? soy.leg.ogh. And this is what we will normally type bash, but here we are going to use not subprocess directly, alright, because as I told you, it's going to be very IO intensive and block event loop, so we use this little function here called run subprocess, which will try to call create subprocess exec from async IO with the command. So if possible, we want to use this utility here, because YTDLP is not async built, right? It is a synchronous library. There is an async wrapper for it, but I didn't. It looked a bit outdated on the GitHub, and I didn't want to use it. Instead, I wanted to show you how to, try to use blocking libraries in async code. You can use create subprocess exec, which will call this subprocess and wait for its completion. We communicate with the process and the classic stuff. If the return code is bad, we raise an exception, which will be caught by our top level function. If your environment don't use async IO subprocess, then you don't have the choice, you have to run it blocking. So with the classic call of subprocess.run. Too bad. Alright, but this does the trick of turning blocking IO subprocess into a less blocking one, I would say. Also, what was really painful is downloading stuff with YouTube, because you have with YTDLP, if you try to download videos from your server with YTDLP, YouTube is rolling cookies like crazy, so you have to extract the cookies in a private sessions, make sure they are not rollback, export them as text, use them in the command. The thing you can use it with like you can use shape of YouTube with Dailymotion or BitChute or whatever, anything supported by YTDLP. But I figured out people would want to use it with YouTube, so I did it with YouTube. It's called the shape of YouTube. Right, we get the duration of the video, its title, the URL link. Very good, we can return this information. Let's see then what we are going to do with that information in the main loop. Okay, we unpack it here. If duration is not between 0 and 60, we raise an error and stop the communications there. And we publish an update to say, alright, I will now start downloading your file. So this time it's going to be a call to download video, which is a coroutine that I wrote, and it's the exact same stuff as before, but instead of skipping the download just to get the metadata, we are going to download it for real. So this is, you were wondering, the command from YTDLP. This is for the format that we wanted. We are trying to download an MP4 and we output it to what we want. So the UID that we generated in the main function. Alright, it's going to be time to extract the frames of this video. We create a folder and we are going to use FFmpeg, I don't know, to slice the video. Once again, AI is really good to navigate the thousands of options of FFmpeg. Here is the command that I am using to output JPEG, really compressed files from frames in the video. And we are calling run subprocess to run this command. So all of these tools are going to be installed not system-wide on my Linux, but with UV. At least for YTDLP, I managed to use UV on the Python wrapper. You know, the UV package manager. Maybe I can show you the deployment at the end of the video. Yeah, I will do that. But FFmpeg, I didn't manage to package it right, so I installed it system-wide on my server. And on my dev environment, I just had to put, the X file of FFmpeg, ffplay, ffprod in the root folder, and it worked. It didn't work on Debian. I don't know why. I put it system-wide on the server and I'm done with it. Then we are going to be analyzing these frames. What does it mean taking the colors from a frame? Because there are a lot of colors in a frame, but we want to try to take the mean colors. We could just count the pixel and take the, for example, 2 colors that are there the most. But what we want to do is take the 2 colors that are the most representative of the frame. This is called using k-means, and you're going to learn something. Don't worry, it's really useful, not in real life, but if you're trying to, have a career in artificial intelligence, to not be replaced by our robots overlords, this can be useful information. How does the k-mean algorithm works? K is like a value. We are going to take 2, so the mean 2 colors of this image. It's an algorithm. You start with 2 colors. For example, I took black and white here. And then from every pixel in the frame, you sort it either in black or either in white. Imagine you take, for example, this blue pixel here and you say, yeah, it's closer to white, so let's put it with white. Like, take some orange light pixel closer to white, there's a white pixel here closer to white, tag, tag, tag. You sort them into two categories, pixel by pixel in this image, either this one or either this one. So you have two packages, closest to black, closest to white, and then you take the mean color of those packages. So this mean color will be mostly blue, and the mean color of this package will be kind of cream brown. And then you repeat until convergence this process. So instead of black and white, you now have this blue and this red here, and you're asking pixel by pixel, is it closer to this blue or is it closer to this orange? The notion of close, we are going to be comparing them in HSL space, more on that later, but the important stuff is that it's a really simple algorithm and it's guaranteed to end because there is a finite state of possibilities, and you are going to be able to find the minimum of this algorithm. So you will have the most representative colors of the image. What is nice is that you can do it with 2 colors, 4 colors, 7 colors, whichever. So for the cat video I did it with 2 colors, you can see them. The most representative are blue, the kind of green that doesn't appear per se in the frame, but is the mean of all the green and dark stuff that is happening. Alright, this is with 2 colors. For Space Odyssey I did it with 7 colors that you can see here. From 0 to hero I did it with 7 colors as well. And there is the means of this frame. It's a very simple algorithm. It can be quite CPU intensive. We are not going to develop and code our own. We are going to use SciPy and NumPy to do it. It's still going to be very CPU intensive, so remember what we saw in the diagram before. We open the image with Pillow, convert it into an array with NumPy, we do some reshaping, some blah blah blah. We called k-means from NumPy, so the function is from Python import solution. I could have coded it, alright, but this project was enough work as it is. VQ, blah blah blah, so the standard stuff. Basically you have a function work which is going to call NumPy, SciPy and tell it to do its stuff. For every mean or centroid as they call it, you put the color and the percentage of the color that you found and you return the results. And if you remember what we said, we define this work function and then we are going to call async.io to thread, because calling it directly would take a lot of CPU time. So we have this to create a virtual thread on a single processor core on our VPS, which is really nice. Alright, now we have the colors. We are going to build the page, the HTML page for this video. It's easier if I show you how it's done. Grid template row, as you can see here. So repeat 63. How does the page knows that it's repeat 63 and here it's going to be repeat 55. We are building it on the backend. Alright, we know that. We can put it in the CSS. Then we have a div for each frame. See here, sorry, up all the divs. Alright, the div is like for the 7 colors And for the percent, we put simply a percent of the height, the div. So 7% of this gray, 6%. That's all the results of the analysis. Define a height for the element, and then inside this element we're going to have percentages of height, and we fill them with the color that we want. Right, pure CSS, no need to resort to canvas or such. It would look nicer with canvas, but if we can do it, hack it together with a little bit of CSS, then why not? This is the classic process of building a web page. We are going to take all the information that we want, the name of the video, the URL of the video for the clickable title here, and then for each frame we are going to construct yeah, alright, let's do it. We get the analysis, we get the frame file name, we convert from RGB to HSL, compare colors not in the RGB color space but in the HSL color space. Why, are you going to ask me? But because in the shape of movies, this is what Jean-Baptiste did. So we are going to try to recreate it as closely as we can. I have here two functions to sort clusters. I can either sort them by percentage, so that will be the logical option. Biggest present color would be on the bottom every time, for example, but it chose to sort them in HSL space, so we have another function. It's really easy. Sorted clusters key lambda RGB to HSL as the key function comparison. Maybe I can show you an example of what the data looks like from a video. With TinyDB it looks like a JSON. You have the details on the video on the first table with the length in seconds, name, URL. Zoolander is a video that I removed, but is the Zoolander meme. And then for each frame you have the analysis with one color, the RGB, the percentage, another color, so we are doing k-means equals 2 here, the percentage, blah blah, and the frame name, and then another entry for another frame, and then another entry for another frame, blah blah blah. This is just like pure data from extract and processing of the video that we store in JSON format with TinyDB, nothing too fancy, and we've done that plenty of times in our previous videos. Then for cluster in sorted clusters, we add them to a stuff called frame list. We add them with some inline style, so they have the right height and the right color, and then we start writing some HTML inside Python. So sorry for the lack of formatting, but for, you know, quick hacking stuff, it's still the best. You can watch here and see the grid templates column. Here we join every frame div, blah blah blah, and then we write it inside our video folder. If anything goes wrong, we raise an exception and we catch it at the top level. Notice this line. If you are a lawyer from YouTube watching this video, I am using OS replace temp-pass final paste to delete the video from the server when I am done. So I am not keeping any videos, I am just keeping the individual frames, because I don't have the storage space, obviously, but because I love intellectual property so much that I wouldn't, you know, keep these precious videos on my VPS. And yeah, that was it. We're back at the end when we take a look now at our process video again. We see that we have get video info, we did that. We have download video, we did that. Some checks along the line to see that everything was working smoothly. We have extract frames, we did that. We have database operations, so inserting or reading operation from a database that we are going to parallelize sort of with async IO2 thread. They are not really that IO intensive, but this is the purpose of this video, so we are doing it. We saw the frame files, we published an update. So, for example, here we have, every frame that is going to be processed with analyze frame colors. We put an entry in the database with 2 threads. Then we define the progress between 50 and 40. We're already at 50%. We have seek the metadata. We have a search for the metadata and downloaded it. We are now analyzing the frames. 50 to 90% are going to be published messages in the Redis communication bus. So analyzed, blah 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 on blah 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 frames. Then we have publish, update, building page, and we build the page. Now this was where I removed the video with unlink, very useful function from the passlib package. I hope that the YouTube lawyers are still watching this video. And when everything is done, we push a complete. And this complete message, when it is read, if you remember, by the application, will be charged with breaking from the async for loop where it was listening for updates. For a fair measure, you can then push a last message to say that everything went smoothly, and the user, if they visit index.html again, you can push them their latest videos that they have used, push them a blank state, something like that. So that's missing here, process blah blah blah. And for the individual video routes, we return the HTML that we previously wrote. Maybe I can find one of these. Let me look at the videos folder. Let's take this one. All right. So this is the kind of HTML that we wrote at runtime to represent the video. All right, this one was, Zoolander again. And this is it. Maybe we can take a look at the site CSS, see if there's anything good. We took the same font than the shape of movies at the beginning because we really wanted to be as close as possible. We are using gold.css for quick prototyping. Status, gallery. The gallery is a stupid grid that changes its template columns on mobiles, small devices. We have the frames. The hovering frames effect that you have here and that I did here is really easy to achieve. Just put the images in the same container as the color bar, and you say display none on these images, but with a position absolute, and place safe in the center, blah blah blah. And when I hover over the div, display the image. So for every div inside frames, I didn't put frame class in every one of them. I just use standard CSS to say yes, they are in the frames container, so that must surely be frames. Let's put them at their maximum width. The individual color bar inside it as well, and the image is hidden until I hover over the frame, and we get this effect. Tada! Which is not bad. Okay, let's run one last video to see everything back in action. What do we have? Oh, the BitConnect one. I really like the BitConnect one. Alright, ready? We are going to be adding another video. Submit. And then we are listening. Up, maybe we can see it from the network tab. What is happening? I can refresh in the meantime. It's not a problem. I will have my stuff back. Yes. See, even if the user tabs out or whatever, whenever some progresses happen, they reconnect to the publication channel. So you don't have to worry about anything. Datastar takes care of that. It's taking a long time to extract frames. As usual, analyzing, I will refresh during analysis and you see that I am still connected, I'm still seeing my updates in the network tab, and we have Waso BitConnect with some nice colors. So I hope that everybody enjoyed this video. Please give a shout out to Jean-Baptiste, to the Cinema channel. I tried to recreate his website best I could. It's not half as good, but it was really a fun challenge to do in Datastar. Not that hard. The hardest part was working with async code. As I said, if you don't have cinephile culture, you can take a look at all the movies that he put in the shape of movies. They're all great classics. He has also an incredible blog that I will put in the description where he talks about his a lot of stuff, playing with Shader Toy, as you can see, posters, math stuff. As I said, he's a really talented game designer. So if you're trying to make a game, go read his blog. A lot of useful insights in it. I will upload this video, send it to him, and I hope that he will like it. This video took a lot of effort to make, obviously, but you will have the source code in the description as usual. So if you want to run a local copy, it's really easy. You just have to type uvsync and uvrun app.py and you're good to go. If it doesn't, you tell me on the Discord. I hope also that you notice that you can see me way better now in the videos. So I did a revamp of the site. I will put soy inside the projects in Datastar that I've already done, but if you want to become a supporter of the channel, now you can. I bought the webcam in advance, but you can help me repay the webcam, for my YouTube expenses. Thanks everyone for watching the video. I hope that you have fun with shape of YouTube before it breaks, and that I become too tired to fix it. In the next Datastar video, we will again see a lot of funny stuff, so make sure to subscribe and like, and have a good day.